So when dealing with the murky world of pointers, we spoke about operators several times. Obviously, there was the pointer operator itself and the address of the ampersand being used as an operator. So I guess this might be a good time to deal with the other operators available within C and Objective-C.
Yeah. So there's all different kinds of operators. The first question is kind of, what is an operator? So programming languages like mathematics, right? They support this concept of an operator. An operator is really, it's a function that operates on variables or values. For example, you could say that 5 plus 4 contains the values 5 and 4 and the operator plus.
Right, okay.
And the end result is 9, right? So now in that case, the plus sign is said to be a binary operator, which means that it operates on two values. There's different terms for, like there's unary operators which operate on one value. Like you were talking about the address of operator, for example. That's a unary operator. It has the variable that it acts on, and it returns the address of that variable. The plus operator, on the other hand, is a binary operator because it's got 5 plus 4, and that returns the result of that mathematical operation. So there's a whole bunch of different kinds of operators in C and Objective-C and so on. We have different things like, for example, the parenthesis operators, which group the things that are inside of it. There are dereferencing operators for accessing variables off of pointers to structures. So, for example, if you had a pointer to a structure and you wanted to access one of its member variables, then there's an arrow operator, this hyphen. It's actually shown here in the first row, the hyphen greater than sign. That's a dereferencing operator to get to those member variables. Then there's all the mathematical operations, addition and subtraction, things like that. Also, there's the not operator, so you can say that something is not something else. We'll look at all of these here in just a moment. I just kind of wanted to show the list of them to give you an idea of what these operators are. So to look at how you would actually use these in a program, let's take a look at this example program that basically takes a bunch of different variables and assigns values to two different variables and then operates on those two different variables using different operators to get different results.
Yep.
So, for example, what we're doing here is we're declaring this variable A and we're assigning it the value of 10, and then we've got B, which is assigned the value of 3. And then we take those and we use the plus operator. A plus B equals C, right? And so that would be 13, right? And so we do that with a bunch of these different things. I'm going to run this real quick just to show the output of that. So if you look at that then, you've got 10, and then you've got 3, and you've got 13, and 30, and so on. And each of those correspond to one of the operations that we've done here. So we've got A plus B is 13. That's 10 plus 3 is 13. Then we've got 10 minus 3 is 7. 10 times 3 is 30. So you get the idea here. The whole idea is that these operators let you do something with these values and then returns a result.
Yep. Okay.
Now I threw a little bit of a monkey wrench into this particular program because this guy here, where we're doing the A divided by B, this is the division binary operator. So we've got A and B, and we're dividing those two values together. Now, if you look at the output that we got for that, typically if you've got 10 divided by 3, you're going to get like 3 1/3, essentially, right? But in fact, when we actually look at our output, we just get a straight off 3. And the reason for that is because we are dealing with integers here. Remember, we talked about those floats earlier with the floating point values associated with them and so on and so forth. So if we used floats here instead of integers, then we would have gotten the 10 or 3.33333 repeating, right?
But because we're doing integer arithmetic, we only get the integer part of
right,
the division.
it truncates it. Now, I point that out here because it's important to realize that not only do you have to be concerned about the size of the variable and the type of variable that you're storing these results in, but you also have to be concerned about the variables that you're dividing by as well. Even if we were storing this in a float value. So in other words, if I had changed f here to be a float, because a and b are integers, it would still do integer division on those,
Right.
and you would
So you'd end
still
up
get a
with
truncated
3.0
value.
instead of
exactly,
just... Yeah.
Exactly. So if you wanted to, if you're dealing with values that are possibly going to be divided by, or so and so on, that you need to be concerned about those kinds of things, you need to make sure that you're using the correct kind of variables, the correct types of variables when you're doing these kinds of operations. Now, the interesting thing is, this also gives us an opportunity to look at another kind of unusual operator that people who aren't really that familiar with computer science and programming might not be familiar with, which is the modulus operator. So in other words, whereas we're doing this a divided by b operation here, and we get 3 out of that, you might want to say, for example, well, what's my remainder? And that's what the modulus operator is for, and that's what this percent operator gives us here. So we do a percent b will do the division and then actually return the remainder. So if you go back and you look at that output again, you see that you've got 3 with a remainder of 1.
Yep.
Okay. Okay, so going back to our chart, let's take a look at all of the different operators that are available. And also, when we're looking at this chart, I also put these in order of operations. Just like in mathematics, the operators have an order of operations associated with them. So if you chain operators together, there's a specific order that they will be performed in. So looking at the chart, the first thing that we have are things like parentheses. You know, when just like in mathematics, if you put something in parentheses, that's going to be done first, right? Then you have array subscripting operations, which is what's indicated with the square brackets.
Okay.
Now, when we look at objects, we'll see that there's another use for square brackets in Objective-C, but they're also used for accessing elements of arrays. Then you've also got these dereference operators, which allow you to access member variables of structures, of pointers to structures, and that's the hyphen greater than operator. And then the dot operator, which we saw earlier when we were working with structures to access those member variables. Then next in the list is we have the not operator, which is the exclamation mark operator. That basically returns the opposite of whatever you pass it. And of course, I mean, you know, there is no value per se for the opposite of an object, for example. But in that case, because it would be treated like a pointer, you would actually get like a 0 value out of that because it's a number. So you'd get a 0 instead of something else.
Okay.
But if you do a not on a 0, you'll get a 1. If you do a not on a 1, you'll get a 0. Usually not's used for Boolean operations. So you might say, not this Boolean operation, and so it would be, if the Boolean operation returned true, then it would actually return false.
Okay, yep.
Then you have the bitwise not operator, which is the tilde operator. Then you have the dereference unary operators. So, accessing the like we saw when we were working with the pointers. So if you wanted to dereference that pointer, same thing with the address of operator. Next, you have the increment unary operators. Now, what those do is you have like if you have a variable and you use the increment operator on that, then it will increment whatever that variable contains and return that incremented value. Okay. So, for example, if you did like one, if you had a variable had a variable name of I, for example, and you stored 5 in it, and then you used the increment unary operator on that, you would do I++, and that would return 6. Now, there's actually two different forms of the increment and the decrement unary operators. There's the postfix version and the prefix version.
Right. Okay.
And that basically determines whether the plus plus is on the beginning or the end. And in terms of order of operations, the postfix operation takes precedence over the prefix operation.
Okay.
So next up, so basically, those are kind of the unary operators, and then then we kind of get into the binary operators, the ones that take two arguments. So you have multiplication, division, modulus, which we saw in the example code. Then we have bitwise shift, which shifts the bits in a particular value, either to the left or the right, depending on the direction of the angle brackets that you're using, right? Then you have the comparison operators like less than, greater than, less than or equal to, greater than or equal to, those kinds of things. Then you also have the double equals, which is a comparison operator. Now there's an important thing here that a lot of, again, non-programmers may not necessarily be familiar with. A lot of non-programmers look at equals and they say, oh, that's for determining equality. But that's not the case in programming languages, or at least not the case in C-based programming languages. There's two different equals operators. There's equals, that is the assignment operator, in which case you have a variable on one side and you have a value on the other side. And the meaning of that operator is to take that value and store it in the variable that you've given.
So when we say x equals 5, that means you're setting x to be 5.
Exactly. And then there is the comparison equal operator, which is the double equals. And what that does is it takes those two values and it compares them and returns true if they're equal or false if they're not.
So x equals 5 will return true if x does have a value of 5 and false if it doesn't have a value of 5.
Exactly.
Okay.
And you can see actually the last line there, we have the equals operator, which is the assignment down there, and all of the other assignment operators. So in other words, that has the lowest precedence of all of these operations. So you're going to do all of the operations, all of the comparison operations and addition operations and things like that in an expression, and then at the end of it, then you're actually going to use that equals operator to take whatever you've gotten and assign it to that variable.
Right.
So that's kind of how that all works. If you think about it, if we go back to that code, if we, just as an example, if we did something like, int x equals 5 plus 10 minus 54 plus, divided by 33 or something, right? It's going to do all those mathematical operations on the right-hand side, and then finally it's going to do that assignment.
Because it's got the lowest precedent.
Exactly.
Okay.
So, so after the comparison operators, and like I say, you've got the equals, you've got the greater than, the less than, greater than or equal to, and then of course you've also got the not equal to, which is the exclamation mark equals sign. That's the not equal to operator. So if you've got two values, it'll return true if they're not equal, and it'll return false if they are equal.
Okay, yep.
After that, then we get into the bitwise AND operator, which will take your two values and do a bitwise AND on those. Bitwise exclusive OR, which does the same thing with that. Bitwise OR. And then we get into those bitwise operations aren't really used all that often in Objective-C. Probably of those three, the one that's used the most often is the bitwise OR, which will be used sometimes when you need to pass bit mask arguments to a method.
Right.
You'll do a bitwise OR on those, and what that winds up doing is it combines like different flags for the purposes of sending them to another method or something like that. Finally, you've got the AND and the OR, which are used in conditionals, where you might want to do this value and this value, or maybe you want to do x plus, x greater than y, or a less than b,
right,
those kinds of cases. If we look at another example of that, We can jump over here to the code again, and we can say, so an example of that might be something where you might do if, like say x greater than y, or a less than b. So that'll do x greater than y, then it'll do a less than b, and then take those two values and return true for that whole statement if one or the other is true. You could also do the same thing with the logical AND operator, which is the ampersand ampersand.
Right, and that will return true if both sides are true.
Right, exactly. So, and then finally, going back to those assignment operators, again, we talked a little bit about the equals operator, but there's actually a whole bunch of kind of cool assignment operators down there that you can use. For example, you can do like plus equals, which is, the plus equals operator. That will actually take whatever value you are assigning to and add whatever it'll take whatever value is passed on its right-hand side and add it to whatever is contained in the variable on the left-hand side and return the result of that.
So if I say plus, if I said x plus equals 5,
right,
it would take the value of x and add 5 to it.
Exactly. So, and that looks kind of like, if you had like plus equals 5. That's basically how that would look, just like that. And again, it's just a binary operator. And in this particular case, it's taking a variable on the left-hand side and a number on the right-hand side, although the number on the right-hand side could be another variable. So, and it's taking that variable on the right-hand side, adding it to the one on the left-hand side, and returning the results.
Okay.
So it's pretty simple stuff. There's assignment operators like that for all kinds of stuff. Like, there's the subtraction assignment operator, there's the multiplication assignment operator, division assignment operator, basically all the same things that we've already seen in the normal binary operators, you can do also in the form of an assignment, essentially, using those kinds of operators. Right.
I mean, it looks like a lot in the list, but you get familiar with them all fairly quick. Some of them are more common than others, and it's if we've come from almost any programming language, we're going to be used to having to use these operators. It's just what symbol we're using for them.
Right.
On the whole. So tell me about this thing called the ternary operator.
Right. So now there is so we talked about we talked about unary operators, which operate on one variable. We talked about binary operators, which operate on two variables. But there's also this ternary operator, which actually operates on 3 parts. Now the thing is with the ternary operator, it's actually used for sort of a flow control kind of thing. It's used in cases where, again, it takes 3 pieces. So it has the first value, a second value, and a third value. And what it does is it looks at the first value and it determines whether or not that evaluates to true or false. If it returns true, then it returns the first value, or the second value, I'm sorry. If it returns false, then it returns the third value. So let's take a look at that quickly in code. We'll cover this in more detail when we look at flow control.
Okay.
It's a little bit more of a flow control question than anything else. But just to sort of explain what I was just trying to say visually, so you'd wind up with something like x greater than 10 question mark, which is the ternary operator, the first part of the ternary operator, then return 15 colon 5. So in that case, what it actually does is it checks that first value. If it's true, then it'll return 15. If it's false, it returns 5.
Okay, so it's quite straightforward, really. And you say using for doing different things and setting some values. Excellent. Well, I think we've spent quite a while now looking at types and operators and understanding pointers and variables. And people are probably thinking, whew, lots to take in there, but I guess it's now time to move on and look at some code, really, and how we're writing code and functions and things like that.
Yes. Now we actually so we've sort of laid all of the foundation work as far as like variables and statements and operators and everything. Now we can actually start to actually build some of the building blocks that you'll use to actually write code with.
Sounds good. Do that when we come back.
Okay.